My name is Alexei, and I've got a Kubernetes failure story for you today. So we use Kubernetes at my company to deploy Elixir. And about a few months ago, we discovered a problem. So here you can see a list of Kubernetes pods, and some of them are stuck in the terminating state. And if you look closely, you will see that well, there are like pods that have age 22 days, and it's still stuck. So it's just hanging there, eating up resources, but it's not doing anything, and it cannot be killed easily. So we wanted to go and see what's the problem. So if you search on the internet, it's a known issue. Other people have encountered it, and the suggested fix is to restart the Docker daemon on the node where the pod is running. It helps sometimes, but most of the time it didn't resolve the issue. So you can actually force delete the pod, and it will remove the pod record, so you will not see it anymore. But the Docker container will still keep running on the node, so it doesn't really solve the problem. And even if you just SSH to the node where the container is running and try to kill the container, it doesn't work. It's just stuck. So obviously something is really wrong here. And so we tried to see, like, maybe we have resource usage that's over the top. No, there's nothing suspicious there. And the CPU utilization is quite low. And I'm going to try to fix this scrolling. So this is a fragment of the log that we got from the kubelet process. So when you run Kubernetes in your cluster, every node in the cluster runs a kubelet process that's responsible for starting pods that are scheduled in your cluster. And so my coworker Andrew got a hold of a Google engineer, like we're running on Google Kubernetes Cloud, and he got a hold of a Google engineer and sent him all the logs from our kubelet process. And there were like 120 megabytes of those logs, but the Google engineer found this particular line, which is like an error wrapped inside an error and inside another error. And it basically says, like, it cannot create a process. So when Linux cannot create a process, it usually means that it has run out of bits, process identifiers. And so we built a chart that shows the number of bits on the pod. And as you can see, we clearly have an issue here. So we had a leak where the number of processes kept growing, and those are just plain Linux processes, not Elixir processes. So it kept growing, and at some point, like when it reached about 3,000 or 30,000 processes, like it ran out the system ran out of bits, and so at that time the container would be terminated. And then you can see it goes down to 0, and then the process starts all over again. So after a bit of looking at our YAML configs and trying to find the solution, we identified this suspicious thing, which is actually part of our Kubernetes configuration. So every pod may have so-called probes. There's readiness probe and liveness probe. And a probe actually is like a recurrent thing that checks whether your pod is alive. And so you can have a probe that tries to perform an HTTP request against your pod and see if it gets a response. But you can also run a command. So here we run a command, which is just running our Elixir release and running the ping command, which is part of distillery's release script. So every time we run this command, a new Elixir process starts, and it executes the ping. And our running the main application that's and also an Elixir node, it responds with Pong, and everything's good. But the problem is when we start this ping command, the process doesn't terminate. So here we can see the command ps returns a list of all processes that are running on the node. And most of the processes that we saw were defunct. Another name is zombie processes. So basically, those were processes that stopped executing, but they didn't terminate. Like they were still consuming system resources, and like we had thousands of those processes inside a single node, and that was the problem. So the problem actually stems from the fact that so when we prepare an Elixir application for Kubernetes, we have a Docker file, and so we use Docker to build an image, and then that image is run on the cluster. And inside the Docker file, we have the as the command for the container, we use the basic distillery release script, which basically starts the Elixir node. And so so this is standard stuff, but as a result, we get the Elixir process with PID1. And PID1 on Linux is a special kind of process, which is usually like the init process, like systemd and other init processes. And it has certain responsibilities. So whenever you spawn a new process on Linux and it terminates, like its parent process has to claim it in order for it to go away. And so normally when you run systemd, it does that job for you. But when running inside a pod, and we have our Elixir process as PID1, it doesn't automatically terminate those children processes that have terminated. And so what happened is that we basically had those pings that spawned a few processes every time. And over time, they accumulated and they never went away. And eventually, we brought Kubernetes. So the solution was pretty simple once you understand the problem. So there is a special init program that is very lightweight, that is designed to be run inside of Docker containers. So instead of using the Elixir release as our entry point in the Docker file, we define entry point to be this tiny init program. And then as a command, we pass the usual like release script and foreground or console or whatever. And as a result, you can see that PID1 now belongs to this tiny init program. And everything else is started as a child or an indirect child of that program. And so this solves the issue. And if we look at the graph, like you can see like on the right, when we deployed the fix, we no longer had the growing peaks. So the takeaway here is that it's good to measure things, but it's better when you know what to measure. Like if we didn't get this graph from the Google engineer, we probably would have spent a lot more time looking for the problem. And it's also useful to be like generally aware of what goes on in your technology stack, not only in your application, but below that. So in this case, the problem was both related to Docker, to Kubernetes, and to Linux. And like you had to understand some parts of the whole stack to actually fix this. So thank you. That's my talk.
So the conclusion is, don't run the bare ops, run it through the tiny or other initializer. And must be the good practice.